Okay, fine. So Jeroen here is with SixXS, and many of us are familiar with his group, because many of us have tunneled IPv6 in order to get it running, because our providers have left us high and dry for a few years. So we've all really appreciated the work they've done, and so we're going to do a little more IPv6 today.
Okay, hi. So I'm Jeroen Massar, or in Dutch I would pronounce it as Jeroen Massar, but it's always very funny to explain my name. I have two hats. As a private thing, we run for the last, well, somewhat 10 years, the SixXS project, and as a work thing, I work at IBM Research. There's a clear distinction between them, to make it clear. So, as you might know, SixXS is a tunnel broker. We have been doing this for quite a while now. We originated in the Netherlands. Together, I do this with Pim. His face will be showing up later. So we have about 15,000 active users. Over the many years, about 40,000 or something actually tried to sign up. A lot of them were rejected over time. We have boxes all around the world. More or less. We have now 6 continents because even Brazil is included. And South Africa will apparently also be coming soon. We're always welcoming more, of course. So we started out as IP and GNL. That was really a hobby project of Pim. And I just got DSL at home. I always had connectivity at work. But because, well, you get one IP address from your provider, and that's of course not enough if you have a couple of boxes at home. I found a way to get from work or from the school to my home boxes. And IPv6 was a great way. So I joined that project then, and we started expanding it. And at a certain point, we ran into a lot of limits. And one of those limits were, well, scalability, management-wise. We did everything more or less with simple bash scripts and so on. So that didn't really scale. And it took a lot of time. So we decided to meet up and to do a more... Oh, wait. I'm talking ahead of my slides. We started later on doing more stuff. So in the beginning, we only did the standard ITF Protocol 41. Of course, this is static only. If you have, especially around around 2000, a lot of people didn't really have long lease times on the DHCP, or they were still using PPP. So they had IP addresses with disconnect, which is also something that you have in like Germany. Every 24 hours you get disconnected for accounting purposes. So what would happen a lot is that we would get abuse complaints because people would receive Protocol 41 packets in their firewall and it would go completely ballistics because, well, in 2000, who knew what Protocol 41 was? So there was a big issue with that. So what we came up with is then protocols will actually cause that to avoid that issue. So this is the generic setup that you have. You have a tunnel broker box which is hanging in the middle of your network. It has v4 and v6 connectivity. You have your end host, which is the U at the bottom there, which has v6 and v4 also. But that cloud you're in, you're connected only to v4. So you can make up a tunnel through, well, just through the IPv4 cloud by sending IPv6 inside IPv4. And then you can reach everything on the IPv6 side, of course. So that's the standard definition. So what we then came up with is SixXS, which was not more than, so the IP and GNL setup was just one little P200 megahertz box in Nikhef in Amsterdam, directly connected almost to M6, so that was pretty cool already at the time. But we got requests when David Kessens from Nokia, he was the IPv6 working group chair at RIPE, and he invited us over to RIPE and so on. So we got in the policy process, we got to talk to people like, well, you guys. And that way we got a lot of contacts, and people were actually asking us, well, can you do this by setting up a box in our network so that we can provide our demographic users or our user base with IPv6 connectivity without us having to do much work about it? Because setting up tunnels, it is simple. I mean, you can set up 10,000 tunnels in like 5 minutes. That's not difficult. The problem is having all those users and helping them out and getting them to configure it and keeping it actually working. Because there are a lot of IPv6 kernel bugs which have been fixed in the last couple of years, fortunately. But scalability is something funny in those things. So anyway, then we came up with this SixXS project, where we would provide it more for multiple people, not only for the Dutch user group, although we also had foreign users on that box already. And we, decided to do more POPs then. And we got a couple of boxes already. We had then the IANA box in Ireland, and we had a German box. And so we had three POPs where people could connect to. So you connect to one POP per tunnel. They don't do failover because they are, of course, at separate ISPs, so you cannot do the routing and that sort of things. But generally, the boxes don't fail. As long as you have power, you have networking working, it will keep on working. So as it says here, well, the ISPs won't carry the routed traffic, so we do stuff like also RPF filtering and so on nicely. Well, of course we got, because everything was donated, we didn't really get a pick of what kind of hardware we get. So we support basically every BSD, every Linux, which is almost out there. And I think we used to have boxes running on NetBSD, OpenBSD, FreeBSD, and of course all the variants of Linux. Currently it's only FreeBSD and Linux, Debian and Ubuntu boxes because of management issues. So, well, that's me and Pim. For people who don't see him, Pim doesn't do so many presentations anymore. He's too busy with life and so on. So we designed the SixXS V1 system at one point, but we were not completely happy with it. So we, of course, redesigned it again with all the experience that we had over the 3-4 years that we were running it then. And we came up with this white label thing. So technically we could also give an ISP like a box with their own website front end, and that they can simply send their users to it, and that it looks like theirs. So the design sort of looks like this. You have a toolkit, you have your routers, and we have a central management box, and this one controls then the POPs by just connecting to them, configuring them, and so on. As it says here, by the way, this was mostly written, the backend is mostly done actually in PHP. We found that the appropriate language at the time, especially also because we have, of course, a website where people can use it from, and then the backend, so the shell, the command line, is the same language as the front end, which is quite useful. So it still was not automatic enough, though. We didn't have direct updates. Sometimes the POPs desynchronize and so on. So also, like, the tunnel setup was more or less a PHP script which would call system with the tunneling information, but that didn't really work. So we came up with V3, where the design is on the right there. It's a lot more complex. You can probably zoom in on the slides if you want to see it a bit more in detail. If you want to know about that, just ask. I can give better details than what is in the slides. At that point, we switched more or less. So the central management interface was still PHP based, but the code running on the POPs is now fully C based. We have our own daemon. Basically, we almost do our own networking. So we have our own IP stack in there because, well, as I said, kernels are not really scalable built for 5,000 tunnels or something. Like ISC's NNTPD, for instance, if you run that and you have more than 300 tunnels, it aborts because, well, it's not made for doing that. And you run in a lot of artificial limitations or scalability issues where people didn't expect you to exploit the system in that way. That's simply how it is. So this is then also a routing daemon, and the advantage is also because we now are running C, we could also do our own tunneling protocol, and which I'll have a couple of slides about further. So we have tick, which is also I have further on, and AIA and heartbeat. So then it looks more like this. You have now also the capability to go through a net, and that is of course very useful because most people actually are behind a net at home. So if you have a laptop, you're generally behind a net and you're not having a public IP address. So to address the first issue what I mentioned before, like that you were getting protocol 41 packets at the at the firewall of a simple user, because they would request a tunnel, their IP address would change, and then they would move away. They would not be there, and another user would get the IP address, and then you get abuse reports. So what I came up with is a very simple UDP program, or a program which sends UDP packets with a heartbeat. So basically an MD5 hash and an identifier so that we know that that user is who. And because you then know from which IP address it's being sent, you just realign that tunnel to that IP address, and you can basically freely move around. As long as you have protocol 41, of course, because if you have not a public IP address or not the ability to tell your NAT box to forward protocol 41 packets to you, or to your host inside that network, you will have no connectivity, of course. So to solve that problem, we came up with this protocol called IANA, anything and anything. And this is basically IPv6 inside UDP inside IPv4 with this heartbeat property. Actually, the trick is that every packet inside being sent by IANA is signed by your password that you get for that tunnel. And that way, we know that the packet is really originating from somebody who owns the password. And that way, you, of course, have more or less a perfect mobility solution because it will go through any NAT. Most firewalls, unless it specifically blocks that port, and it will just work. Like here you have native connectivity, but if you're like upstairs in the hotel room, I just turn on my tunnel, I have V6 connectivity. If I'm at the airport, it works. It's great for that purpose. It lowered a lot of problems for people because a lot of people cannot set up protocol 41 tunnels because they're behind NATs, of course. But it also made it much easier to debug issues because with protocol 41 you don't have a knowledge on the server side, so on the POP side, if the tunnel is actually live or something. While with IANA, we can at least see that where the person is coming from, what the IP address is, and if those packets are properly signed, and if they are actually, when they last arrived. So I can say like, well, your tunnel has not sent a packet for the last week now. Well, with a protocol 41 tunnel, if you have a standard FreeBSD or Linux box, and you don't do instrumentation like would do a TCP dump or something, you would not be able to find this out. And that helps a lot in debugging. So for actually configuring those IANA protocols and the heartbeat and everything, we have this protocol called TIC. I have written a client called Yuku. That's this thing. This is the old Windows interface. I still have to update the user interface and so on with the new version. But basically you have an executable, you install this thing, you install the TUN-top driver from OpenVPN, and you have V6 connectivity. You just type in your username, your password, press enter, and it works. And a lot of people who do not have any technical expertise to set up IPv6 tunnels, especially behind a NAT, they apparently love this. As the tunnel count also shows. Because I think recently IANA tunnels have exceeded the amount of heartbeat and static tunnels together. And so these protocols have also been implemented by AVM. Well, probably you know AVM. They are one of the few DSL box providers which actually do V6 natively, which is really cool of them. It's also cool that they actually implemented this protocol then in their product. Well, of course, one thing that is really annoying with running a public service, which is free, free time and money-wise, is that you get a lot of people who abuse. Especially a lot of people will love to go on IRC, show off their cool IPv6 address, or even cooler, their nice, I'm the king of the internet DNS, or reverse, of course. And that caused a lot of issues. And generally what it amounts to is that people will end up DDoSing the POPs or our websites and that sort of things. So from that perspective, we solve this mostly by having quite strict sign-up rules, asking for people's user details. Although the user details is also more or less a requirement from the perspective that we are providing, of course, internet connectivity like any ISP does. So if you sign up to your DSL provider, you also give them all your details. And we register if you're in the right region, also your details correctly in the right database. Well, a reference at least to those handles. So from that perspective, we also have to provide those things. And that's nice. A lot of people seem to have, are avoiding SixXS, especially when they have abusive intent, because they know that it will not have much of an effect. Because if they are abused, they get shut down, and we're not going to give that guy connectivity anymore. And that's, I think we've solved a lot of abuse issues with that, especially DDoSes. Common issues actually in IPv6 deployment, which is probably a much more interesting subject for people who are actually trying to deploy IPv6 to their end users, is the problems that you come across for the end user for deploying IPv6. It's something that Google is also trying to, or well, showing quite clearly by having these whitelisted DNS servers. The biggest issue actually that I have seen is not circumvented by that. Because if a user enables IPv6 on the laptop, which already happens if they install, what is it called? You have one of these torrent clients which automatically installs IPv6. Because when you have Teredo, you can of course connect two boxes directly and it will just work without having to do all kinds of NAT, PMP tricks and I don't know what. And the biggest issue there is if you have an IPv6 stack enabled, there are a lot of stupid NAT boxes, so your DSL router and I don't know what, those things, that will drop Quad A record queries in their DNS recursors. So you will just go to google.com. Ubuntu has a nice, very long bug report about this also, because people were hit by this. It will send your client DNS will send an AAA request. The NAT box will intercept this sometimes even, or it will be redirected to it, and it will see like Quad A. I don't know what it is, and it will just throw it away. What will happen is your DNS client will have to time out before it will actually be able to decide like, hey, well, I'm not getting any response. Let's send an A record request, which is then, of course, accepted. But the user, they see that basically, well, you type google.com and you go and you're waiting for 5 seconds and then you get the website. So thus, the conclusion is IPv6 is broken. And I think this is currently the biggest issue with IPv6 deployment. Not even the problem of broken connectivity, which has been solved much better lately. Although that's the other problem indeed, and that's what Google tries to circumvent with the whitelisting thing, is that if you publish Quad A records and somebody has broken connectivity, you will of course have that the packets go into the middle of nowhere, and you will also get the same kind of latency timeouts. I think that's only a 20% user base that will be affected by this, especially as most consumers are now using either XP, Vista, or, well, probably by now 7, and that sort of operating systems. When you enable IPv6 on these, they will set up Teredo, and Teredo generally works, which is pretty cool. So they will not have the broken connectivity issue, but the DNS request issue is very prevalent in a lot of DNSL routers. So that's, well, routers and NAT boxes. So that's something that you definitely have to, if you start thinking about deploying v6, is definitely something that you have to think about. And probably even now, you might want to check this if you have like the CPUs are owned by your own ISP and you're deploying this to your users, that you check that these DNS recursors on those things actually understand Quad A records. Because if they're dropping them, your user will now already have IPv6 issues, even though you didn't do any IPv6 at all anywhere. Of course, there's a lot of misconfigured firewalls, and people just randomly block things. Stuff breaks. The black hole issue. And a lot of misunderstanding. If people misconfigure something, or try to put 1/64 on the tunnel interface, and also on their home network, of course, you can only have a prefix at one place, so that doesn't work. To show you a little bit of the backend, what we use to administer SixXS, this is the shell. As I said, it's basically PHP script. I mean, you use hashbang bin PHP and you call the script. So we just type sadmin and we have all kinds of standard tools. And this makes our life, of course, very easy. We can just do a user approve, mail user approve, and they get an approval mail and so on. Reviewing is even easier. Then we have sadmin review, interactive. We get the user details in the screen. I've cut them out of the slide for, privacy reasons, of course. And then we get a standard list of rejection reasons or approval reasons. And then it's just yes, no, and that's pretty quick. And of course, as this said, if people provide whiskey or something, that's always a good thing, of course. Another thing is that we do, which is not the tunnel broker portion, but is related to the IPv6 deployment, which is why it's included in SixXS, is this IPv6 Gate. It's wildly popular among Chinese people, because in China, SerNet and a couple of other networks are IPv6 only, apparently. And so people have, of course, two problems there. They have no IPv4 address in some cases, and they go then for IPv4 connectivity to this nice, now I lost the name, there's a nice protocol for that, so that translates automatically between v6 and v4. But they have a bigger issue. They have this Chinese walled garden. So they have a huge firewall around the country, so they cannot go to CNN.com, Wikipedia, and a lot of other sites, which are politically incorrect according to them. So what they do is they go to www.google.com.6xs.org and effectively connect over v6 to a box which is in the Netherlands, or well, we have a couple of hosts which serve this. And the v4 request from that box, which is acting as a proxy, goes out over v4 from Dutch space, which is of course not blocked. So suddenly they can reach everything in the world, which is quite nice. I think it's one of the more legit IPv6 traffic carriers for that matter. The other way around also works, of course, because you have situations where you want to see the dancing game at www.game.net, so the nice turtle. And if you don't have v6 connectivity, you can just use the IPv4 version, and you can get from v4 to v6, which is also useful. In case that you don't want to set up a tunnel, but just want to reach a site which is v6 only, for instance, or v4 only for that matter. Then we have this nice little GRH project for monitoring routing tables. Because there were a lot of issues. As I said, connectivity used to be quite bad. There used to be a lot of ISPs which would just route 20,000 miles around the world. They would go from Europe to Hong Kong, back to the US, to Hong Kong again, or to Japan, I don't know what. And you would crisscross around the world. You would have 600 milliseconds latency, and IPv6 was really considered to be bad around 2003, 2004, routing-wise. With this tool, we were able to detect a lot of issues. You can click around on the website and you will see what it can do, or check a couple of other my presentations that will detail it a lot more. So it provides a looking glass. It has peering with most IPv6 connectivity game players. So we have a big view of the internet, not much unlike this. And it provides a couple of tools for doing specific IPv6 debugging, seeing what paths it has. It has this. The main reason for it was also where we built it was because of ghost root entries. The thing was that some Ciscos, although the bug has not been totally fixed yet, sometimes forget to withdraw a BGP announcement, and thus they think that they still have it, so that's what they tell their further peers, but they actually don't. So you're sending packets to that box, and the box is like, yeah, what do I do with it? So it doesn't know about it anymore. And we took a lot of those out of the system, which helped IPv6 stability a lot. It also has a distributed looking glass, which allows you to basically do a trace route from all the POPs that we have deployed, which is of course useful because we have now something like 19 countries in there and several ISPs. So you will be able to trace route from all those ISPs, which gives you a much better vantage point on if you're just being able to trace route from your own network, for instance. We also have a ULA registry, because as you might know, you have two types of ULA. You have the locally assigned ones and you have the registered ones. The registered ones have not been standardized in the ITF. The locally assigned ones are not really unique according to some people, so they're not totally happy with it. This is a sort of a bridge between the two. It gives you a list, and as long as you use that list, you can be sure that at least you're unique for that list. Of course, if somebody doesn't look at that list or they go somewhere else, then you don't have that uniqueness property, of course. But as there is currently only one of these registries, this works quite well, I think. It solves at least the mindset of some people who think that the collision factor, which is insanely high, that it can happen to them. Okay, so I'm almost at the end, yes? So what we will be doing for SixXS soon, and then you can start asking a lot of questions and nasty comments. We will be soon be deploying a new sign-up mechanism because a lot of people think that the sign-up procedure is a bit difficult, and some also are not entirely understanding why they would have to provide their username or the real name, their address, and so on. So we will be making it a bit nicer for them. Something that's still on the agenda also is, of course, multicast, because we see ourselves a bit as more also an operational playground where people can test out new technologies, being IPv6 being one, DNSSEC is one, multicast also being one. And of course, well, get IPv4 multicast anywhere. Well, if you're in the educational networks, this is easy. But if you're in a residential network, forget about it. And of course, IPv6 promises that multicast is really cool and that you can use it for everything. So we still intend to provide connectivity for this. This is something also on the schedule for this year again. Then of course, IANA at the moment does only IANA over UDP. But as I said, like when I go to an airport with that nice development version I have, it also does IANA over DNS. So you don't have these issues with having to log into those websites and so on. This also allows you to basically evade most firewalls and so on, which is of course very nice. A new Yuku client, one with a new web interface, also for all the people with Macs here. I mean, like 10 years ago, everybody had a ThinkPad. Now everybody has a Mac. So we only have a Windows, the Windows user interface. We don't have a console client for the Unix variants, as I would call it. And I come up with a nice user interface implementation, which is cross-platform. Well, something that a lot of people will always ask is BGP support. The only thing that we have an intention of one day maybe doing is that you can have BGP between two POPs of the same provider. So we have a couple of providers like EasyNet who are really cool. They provide already like 5 boxes now or something. And because that's in the same network, we are able, of course, to do a little bit of BGP, at least between the POPs, so that if one box goes down, that they can fail over to the other one. It doesn't happen often, but sometimes boxes are not as stable as they should be. The community edition that mention is a bit more from the complaints that we sometimes receive, that people think that we're a bit harsh with reviewing. So recently we have been appointing people to do reviews for us, which means that there are more eyeballs looking actually at everything basically, also info at and so on. There's now I think 7 people looking at that in total. So that is hopefully also helping up a lot more. Which also means that there's a lot more support in the forums and so on. And of course, more POPs. Well, so from a perspective, most of you people here are ISPs or providers in a way? Time? Oh, okay, good. Yeah, I see here. So, I have 2 slides. So what we generally do is just very simple. An ISP comes to us and they say, well, we have a user base. These are the policies that people who should use it, the service. They hang up a box, a real one or a VM. They route one IPv4, one IPv6, a /40 to it, IPv6 of course, a root SSH key, and they install a Debian default or an Ubuntu default, whatever is the preference, or a FreeBSD if they really need. And we take over the rest. According to their policies, we just run the box and so on, and that's how it works. And then you, of course, get that your user base has IPv6 connectivity over tunnels, which is probably very useful if you cannot deploy v6 to like your native end users. We handle all the sign-ups, all the user interaction, which is probably for an ISP probably even the bigger problem than actually getting IPv6 deployed in the core. I think deploying IPv6 in your core network is quite easy as long as your routers support it, and otherwise you can use an overlay mechanism, of course. The next difficult step is, of course, getting native connectivity or some kind of method like the new 6RD stuff from Free in France to get it to the end user. The biggest issue is training of your help desk because you will get support questions. And this will be the biggest issue. And this is something, of course, because, well, we have been doing this for now quite a long time. We know most of these issues, so we can give a standard response or at least help these people out because we know what the issue might be in those cases. It's, of course, for free. We do this in our free time just for the fun of it. As I said, I started out playing with it as a student. I learned a lot from it. And it has been nice, right? So, any questions?
Hey folks, anyone want to talk about what they like, what they don't like, what they wish they saw more of, what they wish they saw less of? Talk about, do you want to pimp some more of this type of tunneling? There we go, hi.
Carl Certify. Have you noticed any increase of abusive use of your service?
How do you mean?
Have you noticed any increase of abusive use of your service by the, I would say, botnet CNC or operation or something like that?
Yeah, so recently, apparently YouTube put Quad A records in DNS. So if you are whitelisted, then you will see traffic. But the only place that we actually saw traffic, because Google doesn't publish this information, of course, is at DACX, which is the German Internet Exchange. Now, there are not many ISPs in that area which actually have whitelisted DNS resolvers, so that's a bit weird. And also because from what we know is that the biggest deployed base is actually in, well, France has a big ISP, of course, FreeFR. They didn't see any spike. So we're still wondering if that spike was actually related to YouTube or not. But yeah, the only people who can tell you this is Google, but they will probably not tell you the traffic details, unfortunately. But the uptake in the last couple of years, yes. If you look on the website, you will see we have trends of, well, basically all the figures, all the statistics of SixXS are public. You just have to find it on the website. It's probably under MISC tools, and there's probably a usage statistic there. And I think the scale is still upward increasing, that there's more requests coming in, yes, over the years. It has been getting busier, which also means that, well, we have more work to do. If you look at TLA allocations, of course, so the people who are getting prefixes from the registries, it has been increasing dramatically in the last 2-3 years, which is good, of course, because if you don't do it now, you're too late.
Well, my question was actually not on the use of the service, but on the abusive use of the service.
Abuse. Abuse has gone down. Because there are other services who also provide tunnel broking services, which are easier to abuse. And if the abuse threshold for us is so high that people do not bother going to us. And that's why we did it also, because all the infrastructure is donated for free. If an ISP is donating a service for like a box with connectivity for free, and they're getting DDoSed to smithereens once in a while, which affects their paying customers, they do not want to provide this service. And under that premise, we also, well, we have these very strict guidelines to avoid this, because, yeah, well, we don't want those people to be abused or DDoSed and then say, well, we take the box away because, well, it's only causing a hassle for us. So that's, yeah. Does it answer your question? Okay.
Thank you very much.